Hi everyone! In this video I want to talk about Microsoft Foundry because I'm coding models, but the moment I try to run an agent in production with real data and real security, I realized the model was the easy part. Right now everyone is coding models, the API works, the answers come back, but a model call is not an application. I need a way to pick the right brain, run the agent loop, connect tools and data, and still be able to govern it like any other workload. So I'm going to build that mental map of Microsoft Foundry today, one layer at a time. So in Microsoft Foundry, I get a unified model catalog. Think of that like an app store for AI brains. I browse, I compare, I try the same prompt side by side and pick what fits. And the key part is someone else is keeping that catalog maintained for me. So I'm not chasing links and random repos. That catalog is huge with thousands of models. It includes Azure OpenAI models like GPT-4o and GPT-4, Microsoft Family, those small language models tuned for cost, and third-party models like Claude, Llama, Mistral, Grok, and Black Forest Labs. And if I'm using open source, I can also go via Hugging Face. Now, picking the model is only half of it. The next thing I think is where is this actually going to run? Cloud is the default, it runs on Azure infrastructure, it scales and it's managed, so it's perfect. But not everything has to be in the cloud. There is Foundry Local, at time of recording that's still in preview, where I can run models on a local machine, and that's great for SLMs like Phi. So imagine a factory workstation. If it has no internet, the agent can still work. And then there is Edge as well, like IoT or mobile, where I'm running optimized models too. Once I know where it runs, I need to decide how I deploy it, because that shapes cost and performance. So you have standard deployment, which is pay as you go, which is where I start for dev and bursty workloads. You have provision, which is where I reserve provision throughput units called PTUs. So I get guaranteed throughput and lower latency, which is what I care about for production. And there is also batch deployment, which is asynchronous. It's great for large jobs and it gives a big cost reduction, but I accept it can take up 24 hours to finish. The last option is priority processing, which has been released recently. It's like the pay-as-you-go option, but with SLA. And then there is a data residency scope, which is separate from the deployment type. Global can use any region. Data zone keeps processing within Europe or in the US. Regional pins it to a single region for the strictest compliance. And finally, there is a really useful concept called model router. It's a routing capability, so it doesn't generate the final answer. It dispatches, it looks at your prompt and routes it to the best target model. So math problems might go to a reasoning model and code might go to a code model. And that's how I start balancing quality versus cost without hard coding every choice. Now that I have a model, I still need an agent. A model is just text in, text out. It doesn't keep the state. It doesn't manage a conversation across turns, and it can't safely do the loop of think, call a tool, take the result, and think again. Now I can build agents in 3 different ways depending on how much control I need. Prompt agents are the simplest. It's configuration, no code, just instructions, a model and tools. And I can create them in the portal or via the SDK, and they are great for prototyping. You have also workflow agents. At time of recording, it's still in preview, but it's when I need multi-step orchestration branching, and even sometimes human in the loop or group chat. And I can define that in a YAML or visually directly in the Foundry portal. Last option is hosted agents, also in preview. It's where I want full control, so I bring my own code in a container. I can use Microsoft Agent Framework or LangGraph or something custom, and Foundry will still manage the hosting and scaling. And then when I want to build my agent, I can use something called Microsoft Agent Framework that's open source and portable across environments for building multi-agent systems in Python or .NET. I can pair it with Foundry Models using the Foundry SDK, or I can run it standalone if I want. Operationally, the lifecycle is pretty clear. I create, I test in a playground, I trace, so I can inspect every call, then I evaluate, then I publish to get a stable endpoint with auto-versioning. And then I need to monitor. That's 6 steps, and it's the difference between a demo and something I can support. And publishing is not just here's an API. I can push the agent out to places users actually live, like Teams, Microsoft 365 Copilot, or the Entra agent registry. Even with the runtime, if my agent can only generate text, it's still not doing real work. In practice, I needed to search, to run code, to read documents, call my ticket system, maybe create a record in CRM. Those actions are the tools. So Microsoft Foundry gives me built-in tools that the service executes for me. Web search is one. It can do real-time web queries with citations. Code interpreter is another one. There is a sandbox Python environment. File search will give me vector search over uploaded docs. And then there are tool calls into my own functions at time of recording. Some of them might be still in preview. And I can also wire in Azure AI Search and Azure Functions directly. There are also a bunch of tools in preview, like image generation, browser automation, computer use, Microsoft Fabric, and SharePoint. I don't need all of them all the time, but it matters that they are there when the use case grows. Now, separate from those agent runtime tools, there is a set of pre-built AI capabilities. In the docs, you will see Azure AI services, and in Foundry, you can think of them as Foundry tools. This is things like speech, vision, language translator, which supports 100+ languages, document intelligence and content safety. They have their own SDKs, and I can plug them in when I need those specific capabilities. And when built-in isn't enough, I need a standard way to connect anything. That's where MCP, Model Context Protocol, fits. I expose a tool via an MCP endpoint, and partners can publish MCP servers into the tool catalog, like the Azure DevOps MCP server, for instance. And then authentication can be handled in different ways, key-based, Microsoft Entra ID, or OAuth pass-through. Another option is the OpenAI tool, where I bring an OpenAI 3.0 or .1 spec, and now any REST API becomes a callable tool. Finally, there is A2A, agent to agent, that's in preview. One agent can call another agent as a tool, and that can bridge pro-code and low-code agents across platforms. All of this is managed through the tool catalog, where I can browse public tools and also have a private organizational catalog for internal tools. And remember, the model only knows what it saw at training time. So it doesn't know my company policies, it doesn't know my internal documentations, and I definitely doesn't know what changed this morning. So I can do classic RAG, inject some context at query time, and that helps. But traditional single-shot RAG is fragile. One query, one index, one shot, and if it misses, it misses. So Microsoft Foundry has Foundry IQ. It's still in preview, but it's a managed knowledge layer built on Azure AI Search. The key idea is I create a knowledge base once, and then I can connect that knowledge base to as many agents as I want. I'm not rebuilding the same index per agent, and I'm not duplicating security configuration everywhere. What makes it different is agentic retrieval. Think of it like an open book exam. Traditional RAG gives me the book, but I can only look at one page. Agentic retrieval is like having a research assistant. I ask a messy question, they break it down, they search multiple places, and they bring me the right pages back with page numbers. So mechanically, here's what happens. I ask a complex question, and the LLM decomposes it into subqueries. Those subqueries can run in parallel across multiple knowledge sources. Then the results are semantically re-ranked, and what comes back includes citations, so I can see where it comes from. In benchmark, at the time of recording, it shows roughly a third better response quality compared to traditional single-shot RAG. So the important part is, this is not just retrieve top 5 chunks and hope, that's it. Now I can connect different types of sources. Index sources mean the data ingested into search index. Foundry IQ will do automatically chunking vectorization, metadata extraction, and ACL synchronization. Sources include Azure Blob Storage, Microsoft OneLake, SharePoint, and even existing search indexes. The other type is remote sources, where it queries on demand at retrieval time, so the data is always current. Examples are SharePoint via the Copilot Retrieval API and web via grounding with Bing. And I can control how much syncing the retrieval does, because that affects cost and latency. So we have minimal retrieval. Minimal retrieval reasoning is up to 10 sources and simple merge and no LLM. Low is up to 3 sources and uses an LLM for query planning. Medium is up to 5 sources and can do iterative search if the first results are incomplete. So if I'm just doing get me the latest policy doc, minimal might be enough. But if I'm doing compare policy A to policy B and find exceptions, I probably need more effort. Security is a part I really care about because knowledge is where people get nervous. For index sources, ACLs are synchronized. So if a user can't access a SharePoint document, the agent won't surface it. And queries run under the Caller's Microsoft Entra ID end-to-end, so it's permission enforced through the whole chain. For remote SharePoint sources, Microsoft Purview sensibility labels are also respected. And the integration into the agent is clean. The knowledge base connects to agent service as an MCP tool called knowledge base retrieve. So from the agent point of view, it just calls a tool, gets grounded results back and keep going. That's a nice mental model because it's consistent with every other external capability. If I've got the model, the runtime, the tools, and the knowledge layer, most of the time I'm done. Prompt engineering and RAG solve a lot, but sometimes the base model behavior is just wrong for my domain. It uses the wrong terms, it won't stick to my format, or I'm sending so many tokens in prompt that it gets slow and expensive. That's where I start thinking about model customization, which is basically called fine-tuning. And I like the new employee analogy. The employee already knows how to think. I'm not teaching them language from zero. I'm teaching them how we do it here. The tone, the format, and the rules. In Microsoft Foundry, the pipeline is integrated. I prepare a dataset, I train, I evaluate, and I deploy, and then iterate. I can do it in the portal or via the SDK. I don't need a separate set of external tools just to manage the lifecycle. There are usually 3 reasons I do it. Adapt to my domain, so it speaks my jargon and follows my output shape. Reduce cost, because maybe a smaller tune model replaces a giant model plus a huge system prompt. And third, reduce latency, because the model knows what to do and I need fewer tokens to get there. Technique-wise, it's a spectrum. Supervised fine-tuning, SFT is a default for most projects, and it's training on input and output pairs. DPO is based on preferred versus non-preferred responses, so I can push quality without building a separate reward model. Reinforcement fine-tuning, RFT, that's in preview, is reward signal learning, and I use it when SFT is not enough for complex reasoning or behavior. And finally, distillation is the pattern where I transfer capability from a large model down to a small one to get a fraction of the cost. So I think of it as prompt engineering is the cheapest and fastest, RAG adds knowledge, fine-tuning changes behavior, and distillation is how I shrink it. When I connect an agent to tools and data, the attack surface changes completely. It's not like a normal app where I control every code pass. Now I have natural language input driving decisions, tool calls that can do real actions, and a model that can be tricked. Prompt injection over privileged access, unsafe tool calls, data leaks, it's all on the table. So the first thing Microsoft Foundry does is treat the agent like a real identity. At creation, my agent can be set up with the Microsoft Entra agent identity that's durable, non-human identity with its own lifecycle, permissions, and audit trail. Then I use role-based access control to give it least privilege. So if I have a document summarization agent, I get storage blob data reader, not write, not delete. If something goes wrong, the blast radius is limited. And this also changes how I think about secrets. I don't put keys in prompt, I don't put secrets in code. Foundry issues scoped access tokens at runtime, so the agent gets what it needs just for that moment. Next is guardrails. I want intervention points, not one big filter at the end. The guardrails can apply at user input, tool invocation, tool response, and agent output. Some of the tool call intervention points are in preview. The actual controls include task adherence, prompt injection mitigation including cross-prompt injection, sensitive data detection, groundedness check, and protected material detection. And then content safety gives me harmful content filters, like custom block list or PII. Now, because I won't behave the exact same way every time, I need evaluations. Built-in evaluators cover quality, like relevance, coherence, and groundedness, and safety, like harmful content and bias. There are also agent-specific ones like intent resolution, task adherence, and tool call accuracy. And then there is the AI red teaming agent, which is now GA, and that runs automated adversarial scanning. It tries jailbreaks, data exposure, unsafe actions, all the stuff I hope never happens in production. And I can run continuous evaluations in CI/CD. We call that CI/CD-E. So every new version gets tested before it rolls forward. Finally, I need to see what it did. Observability is OpenTelemetry based tracing across the full chain, prompt to model to tool to response, and traces from different frameworks like Microsoft Agent Framework, LangChain, and LangGraph can flow directly into Azure Monitor. And finally, there is integration into the security stack as well. Microsoft Defender for Cloud can do AI posture management and attack path analysis. And you also have Microsoft Purview, which helps with audit, compliance, and applying organization-wide policies. The analogy I keep in mind is employee onboarding. A new employee gets an ID badge, explicit access to certain rooms, and rules about behavior. An agent gets the same and Entra identity, scope permissions, and guardrails. The difference I can see here is I can automatically test the employee with adversarial scenarios all the time. So the way I think about Microsoft Foundry is I stop calling a model and I start running a system. The model is the brain, Foundry Agent Service runs the loop, tools are the hands, and Foundry IQ is the memory. For governance, this is the safety net so I can actually ship it. And that's also why it's the pro code pass, while Copilot Studio is a low code pass. And they can still collaborate at the end with A2A when I need both. So that's it. That was a big video with a lot of information. I hope you liked it and it was useful. Till next video, take care.